where we are going to go through determine if two strings are close. So what is the meaning of two strings being close? So here it has been defined that two strings are close if they can be equal after performing any of these two operations any number of times. The first operation is actually swap any two existing integer, two existing character. What does that mean? That means if I have the first character and the second character like this, if by swapping any character here I land here, that means yes, they are close. And the second operation is transform every occurrence of one existing character into another existing character. Let me just grab a couple of examples. If I'm having this, for instance, I have B, C, A, G. So if I want to obtain this, I can swap. Let's say I'm moving from here. I can swap those two first, the G and the A. I will have my G here. The B is already aligned, don't need to check it. I can swap those two elements. I will have my A and C here. And here I will swap, since I will have my A here, I will swap again the A and the C, and then I'll have this character. So basically, if you have if you have a string, and by performing the swap any number of times you end up with another string, thus they are close. The second is if you can transform all the occurrence of a string into another, then they are also close. What does that mean? That means, okay, let me take this one. No matter what the swap I'm going to perform here, I will never have them be the same. But if I swap all the B here into A, I will have 2A and 1B, and from that I will be able to make the comparison and land there. So if I transform the 2B into A, I will have like AA and B, and then those AA I can swap them and put them at the end, at the beginning. I will have my B here, and I will swap the B and the C, and it will be equal to this. So it's okay. So now, given those two remarks, how can I code it to make sure that two strings are actually close? I'm going to first learn on this. To make sure two strings are close given the first operation only, I just need to check if they are anagram. So if every character in the first string appear in the second string with the same number of occurrence of time. Okay, if it's the case, then this swap will actually make them be close. In fact, this swap will actually make them equal, thus they are close. Now I have this second operation which is talking about the swap. So this one is actually making me remove the condition of each character should appear the same number of occurrence, because I can swap them. If I can swap them, I should not more type like A should appear 2 times, B should appear 2 times. No, but I should instead say, if you have a number appearing in the first string with a given occurrence, I should have another number in B appearing with that number of occurrence, because if it's not actually A, I can swap with A. So what I should check is that, okay, yeah, I will create what I will say an array of I will create what I will say an array of occurrence, and I will say, okay, A here will appear 1 time, B here will appear 2 times, and C here will appear 1 time. Thus the occurrences are 1, 1, and 2. Here we have A here which is appearing 2 times. We have C which is appearing 1 time. And then we have B which is appearing 1 time. This B. So this is 1, 2, 1, 1. So if I sort them, I will have 1, 1, 2. So I can see that I have like an equality with the number of occurrence. I don't really care about which one appear which number of time. No, I just need to make sure that they have the same number of occurrence. If they have the same number of occurrence, the swap will help me to kind of attach the exact number of occurrence which the exact number of time to the exact character to make them equal. And then the next check I need to make is make sure that all the characters appearing A are also appearing in B, because here, if you see here, we have a 2 1 and here we have a 2 1, but you can transform this into this. Why? Because no matter what transformation you want to do here, you will never have a B here because you're not actually adding new character. So basically you have two check to make. In fact, three check to make. First check, make sure that they are equal. Make sure that they have equal size, because if they don't have equal size, there's nothing you can do. The second check is that you should make sure that all character appearing in A also appear in B. That's the second check. And your third check is that you should make sure that you have the same number of frequencies, that the frequency of character in A are actually equal to the frequency of character in B. You don't care about the frequency attached to each character, but just the frequency, because you can perform the swap and end up with something that will help you to tie the exact occurrence to each one. So what does it look like in code? The first condition, compare if they are equal. Just need to check if this word size 1 is actually different from word size 2. If they are different, you return false, nothing to do. So now for the frequency, is really up to you. You do whatever you want. I chose to go with string, so I create a string. I create like a string 1 and string 2. This one will help me to compare the existence, because what I want to do is that at the end of the day, I want to construct the string with no repetition. So this one will actually return me A, B, C, G with no repetition. This one will do the same. You actually return me A, B, C, and G. If they are equal, if the sorted string with no repetition is actually equal, then they are equal. And since I know the exact number of character, which is 26, the number of character we have in English later, so I can just use like a kind of counting sort. Yeah, counting sort with no occurrence. So that's why I created this, and you will see why in this logic. And this is the array of frequency. I also use string because I wanted to go with string. So what is happening is now for the frequency, I'm saying that the frequency are actually all 0 0. The frequency are actually all to 0. What I'm doing, I'm saying my frequency of that character, because that character is actually C minus A, will actually be increment. I will say the string of that character will actually take C, because initially it is 0. I initially say that is 0 because at the end I'm going to remove all the 0. That will give me the exact concatenation of the string. So by doing so, I've created my array of frequency and my array of occurrence of string, frequency and occurrence. So what I will do is that I will remove all the 0 in the frequency and remove all the 0 in the occurrence and frequency. Once I've removed all the 0 in the string, the remaining string is actually the like all the string appearing with one occurrence, all the string appearing. So if I compare them, they are equal. That means all the string appearing in A actually appear in B. In fact, all the string appearing in 1 also appearing in 2. So I can already compare them. But for the frequency, I will need to sort them, because if I don't sort them, I will not be able to have the accurate value. So that's why I'm sorting my frequency 1 and frequency 2, and I just return string 1 equal to string 2 and frequency 1 equal to frequency 2. So let us submit this and see what it gives. Yeah, it is working, it is performing pretty well. This is my approach of solving this. And regarding the complexity of this is actually big O of n, because we have the loop here big O of n, we have the loop here big O of n, we have the arrays here which is big O of n, big O of n, big O of n, big O of n, and then n plus n plus n is actually n. We have the sorting here, which is a constant time, because we are sorting an array of 26, which is big O of 1. So big O of n plus big O of 1 give you big O of n, and then you return here, so it's big O of n. Okay, it was a pleasure for me to interact with you regarding this. I hope you do enjoy it. Feel free to leave me any input. I'll be really happy to interact with you. See you on the next video. Ciao.